Hey, how's it going out there, guys? Welcome to the show. Got a great one lined up for you today. As usual, if you'd like to support this channel, there are PayPal and Patreon links in info box below. Got a little open discussion, false advertising today. There was a little change in plans. We got a little small presentation I'm going to ad-lib with, so it's going to be a lot of fun. I put some time pressure on myself, so you know, give me a little latitude today. I cobbled it together, but it's going to be really good, I think. So, well, let's say hello to everyone in Discord. What's up, guys? What's going on out there in Discord?
Hello, hello.
Hello.
Hello,
everyone.
So, oh, there's Adam. Fashionably late.
Rush that tea.
We were talking about you before because somebody asked, "Where's Adam?"
It was me.
Hey, what's up, James? James Mays out there. Yeah, you caught me looking at chat. I usually don't do that. So, how's it going, sir? I told you to hit me up on Discord, man. Long time no talk. So hit me up when you get a chance, man. All right.
Well, Sleeping Warrior says latitudes are concepts. Can't give you any latitude. Sorry.
yeah. Latitudes are concepts, aren't they? Yes, they are. Just cut me a little bit of slack. I think I've earned a little bit of slack through the years.
I can certainly imagine giving you a little bit of slack, so we should be fine.
That's what I thought. That's what I was banking on. It's highly presumptuous, but sometimes I am presumptuous and precocious.
Are we going to go over your character points?
No, we're not. We're going to move on from that. No, there's just too many.
Yeah, exactly. That would be cool.
All right, let's see. Let's get stuff together here. Latitude. Oh, we got 31 viewers. Okay, we'll wait a couple minutes before we get into it. Get everyone settled down. We'll talk about the weather and what Adam had for tea, and by then, we should be good to go.
Stephen Dutton's asked that question in chat. I'm as always, I'm happy to share. It was a bit rushed tonight, and I've had a bit of a delicate belly. So Marie made it was kind of a little bit of a Caribbean take on rice and pea, you know. So I had to like rice and pea, but held back on the spice. And then instead of like a Cajun-y chicken crust, it was just like more Italian herb crust. So an Italian Jamaican cross culture dish is what was tonight's, with a little bit of crusty bread. Quite simple. And a cheeky little, where is it? Let me get it. It's here. It's an Alsace Pinot Gris, which is very nice, 2016. So yeah, that's the food roundup, John.
What the hell did you just say?
Sorry, it's written by me too. What are you talking about? What?
Yeah. So kind of like Jamaican rice and peas, but not done with jerk seasoning, more done with Italian Mediterranean seasoning. Like I said, because I've got that dicky belly.
You got rumpus.
Yeah, I said John doesn't do Mediterranean. All American there.
Who said I don't do Mediterranean?
Oh, come on. We talked about real Italian pizzas, and you said, well, it's American, it's the best.
It is.
Yeah.
See, I win. Yeah, and?
Well, that's it.
All right, who we got in here now? What's going on out there in Flatland? Brian's logic. I'm sure he's muted. No, he's not. What's up, Brian?
No,
Hey Kiwi, hey Betty, hey Adam, hey everybody. How are things?
Good. Your mic sounds exquisite.
Excellent.
Yeah.
Good to know.
Yeah. Everyone's sounding really good. I see Elevator MS Squared's here. That's Deadhead Freeze. Yes, you're going to be a star of the show. We're going to move past you a little bit, though, so just relax. I know you're sticking with your point. We got Sam H. What's up, man? That's been a long time since I've seen you. What's up? Haven't seen you at Coon's age, huh? I unmuted him. He left. Dude, buddy. I have that effect on a lot of people.
maybe it wasn't the real one.
Yeah, it might possibly not been a real one. Yeah, so what's going on out there in Flatland? Anything? Everyone liking the numpty clips? Let me get back to that. One caused a good brouhaha. Gem Panda, thanks a lot, Mr. Rockets in a vacuum. I'll tell you what, folks, those numpty clips are kicking butt and taking names, man. They're starting to gain some momentum. I like to keep that momentum. You got to be sharing these guys, all right? Because I'm not just poking the thumb in their eyes. It's much deeper than that. I would say this is the best flat earth proof. I was talking about it today on Nathan's show. Now, not for brand new flat earthers, right? I would say like a month, like a 1 month to 3 month window that they should hit those numpty clips and hit them hard. In that genre, in that time frame, I think they are the best flat earth proofs that we got on two levels. Number one, it shows the status of where the globetard arguments are, if you call them arguments, right? They're actually not. But they show you what they're talking about, what the tenets of their non-arguments are. But more importantly, how to systematically deconstruct each and every one of them, then laugh at them, and then have your wolf pups eat their entrails. That's why. So get up to speed. Start sharing these things, man. They're impactful. They're documentaries, right? I'm looking for an Emmy or two. And we're going to go over one here in a little bit because, like I said, there's been a change in plans. It was going to be an open discussion, just relax and no big deal. But I was in Discord last night, and I posted Gem Panda's video again just to get everyone, talking about it. And what did I see? Our own Deadhead Freeze posting rocket in a vacuum. Of course, the diameter of this vacuum was not very big, maybe 4 or 6 inches, a little bit bigger than the usual ones. Back in the day, they were like 2-inch diameter, so-called vacuum chambers, right? And they'd light up the fairy tale vacuum or fairy tale rockets in the vacuum, and the exhaust would fill the vacuum, make it a non-vacuum, and then they'd get thrust. Right? Remember that back in 2015? We'd all sit there and laugh at them, right? So Ed posted the same dang thing to me. I said, I'm going to make you a star tomorrow, right? So we're going to go over that. I'm going to play the numpty clip again, and then we're going to look at the video that he posted in live stream. We'll talk about that for a couple minutes, but there's a deeper point behind this, right? And I was thinking this morning, I didn't have anything scheduled. And I was thinking about it, and we were talking about it in VC, and I just started thinking out loud, and I said, I have some research that I'd done on this many years ago. So let me snatch some things together, cobble something together, and I put the presentation together. I was working on it right up until about 30 minutes before the show. So that's what I said. Give me a little latitude. I cobbled it together. It's probably not as pristine as my other presentations, but that's okay. The substance. I want you to see the absolute train wreck that NASA puts themselves into. It's absolutely glorious. I got a warning, though. Don't let Nathan in, because this subject, he loses his mind. If I bring up rockets in a vacuum and then go on with the begging the question fallacy, because the whole thing's moot, because there is no vacuum of space, because it's a second law of thermodynamics violation. So if I go on about rockets in that fairy tale, then he will lose. He's going to lose his mind, right? So he can't come in here. Nathan, if you're listening, turn off now, right? You're going to pull your last hair out and have a cow. But I got to do it. Say again?
And also talk about the ice wall.
Yeah, I could bring up those two topics, rockets in a vacuum and an ice wall. Nathan, it'll never be the same.
I got told off today, John, for discussing within the mathematics of within 5% of something that is only conceptual in their mathematics. So, yeah, I think you probably will. Put him on server mute, Betty, if he comes in.
I don't think I can because I made him a moderator.
Adam, you weren't specific enough because everyone was confused with your 5%. You needed to be hyper specific about that. That's why I think he was a little iffy on it. Right?
Yeah.
Because he thought the radius, you were talking about a radius being in 5%. That wasn't the deal. You needed to give him a little bit of background before he went off.
Well, it was all theoretical and unobservable.
Yeah, it was pretty funny.
The thing with that, John, which I was the point of interest for me and that I raised was really the way, as Nathan says, they try a bait and switch or they try something outrageous to swallow, to move forward from. And that was the outrageous point for me. He made that statement. So if you're going to presuppose that, okay, you're still clinging on to that horizon being a geometric ball edge, but it's moved due to refraction, I'll give you that. And the point I was addressing was on take the black swan, and the mathematics you've stated is that movement is still within 5% of your R value. It's still geometrically defined. But if we take the black swan, and shout out to Gleam because he did the maths for me, it was a bit later in the evening, but it works out not within 5%, but it's within 796% is the actual value. And that's what I wanted to highlight, just the ludicrousness and the misrepresentation that the rumpus does when he comes in and asks and makes a statement of maths, which sounds clever, sounds true. But look at the variance in what the reality of what was observed and what he said, 5%, 796%.
Yeah, well, he's a lunatic. And speaking of the rumpus, if you're out there, the rumpus, you are going to star in a Nupty clip tomorrow, and it's going to be your official end. Take it from me. Now, we all know unofficially that it ended back in June 2016 when I first come out here. Wasn't it just a little baby in flat earth, like 3 or 4 days old, when I drug you around by your short hairs? You remember that? See, that's on my channel, too. That's not just words. So just go to the debate playlist, and Rumpy's in there. That's his unofficial end. He's just been whistling past the graveyard, zombified, ever since then. But tomorrow, it's your official end, and everyone's going to know it. Okay? So stay tuned. It's peachy. Ha! Apparently, obviously, he's not a golfer. Stay tuned. Sorry for that, Adam. I digressed.
No, I think Rumpus is an interesting point in terms of where we are in the flat Earth debate, and Nathan's drawn that line, and I agree with him today. It's until he comes back and admits that he has 2 years, or at least from the point he's taken 2 years ago, that he now takes a completely different stance, which is fundamentally different to what supported his belief previously. He's changed on that. Then it's very hard to see a point in bothering to engage with him because it is lies, and until he can at least admit the truth that's there in all the Nathan shows, from where we've come from, where we've got to, and how the Black Swan has destroyed his previous standing and his verification, and his assumptions, and how it's destroyed that and how he's had to change that. I don't think there is a point in engage with them because it's just ad hominem asking to believe in this false reality they live in, even to the point of changing the reality of their own words over the past few years. It's good.
Yes, sir. Yes, sir. You can't get a word in edgewise. He keeps on interrupting because he knows he's going to get doused by a flamethrower. He knows that. He's a liar. He's a numpty dipshit. And it's going to become painfully clear tomorrow. I mean, numpty dipshit at like a junior high, below junior high intro to physics level. It's going to get this bad. And then the basic reasoning skills, they're below first grade. Everyone knows that. But if you say it with confidence, then it sounds plausible if you don't know what you're listening to, right? But anyone that listens to that friggin' nightmare of an institutionalized paddywhacker, right, knows immediately where he's at. It's just a game. All right, it ends tomorrow officially. So we can move on from him. Stay tuned.
Looking forward to it.
Yeah, I am too. Okay.
To be fair, he's getting replaced anyway by the new top baller to argue with.
Who's that?
That's Arwin.
I wasn't ready for that.
Hello.
Hi, right.
Hey, Arwen.
Hey guys.
Hey guys, that's Flatzoid. That's not Arwen. Flatzoid, are you Arwen now?
I hear Arwen.
You hear
Very
Arwen?
low. Yeah, he's very low.
Oh yeah, you're
Normally,
too
you
low,
are,
Arwen. Hold on, Adam. Let me see if I can hook him up. 1 second. Of course, I got to go back and do this. Arwen.
That Flatzoid as well as, or was it Professor Poisson?
Oui.
Well, that's the point. I raised that because that is the quality of what we've got. We've actually, on the debates, there is no argument. And actually, Arwen's taken up the bat, and you did it tongue-in-cheek with Professor Poisson. Actually, that's a better quality argument to argue against or to argue with for Ball Earth, produced by our own side, than the quality of what's being brought to the table by the supposed real ballers.
Can we get a radio? Hey,
Arwen,
sorry to interrupt,
yeah.
Adam. Need to get a radio check on Arwen. Radio check, sir. Low. Yeah, you're way too low, man.
Just low.
Yeah, and your mic's usually pristine, but over the past couple weeks, it's been bad. You're really low, and I got you almost cranked. Sorry about that, man. See if you could get it fixed and come back in. Appreciate it. We don't want to spend a whole bunch of time on that. Sorry about it for today. You just have to take one for the team today. All right, Betty, any admin, anything else?
Nope. Not anything else. Nope.
All right, listen, guys, we're going to go into this. Like I said, I'm going to play the numpty clip. I am sharing my screen in Discord. This presents another complication. I'd like everyone to have severe mic discipline. Okay, and you can watch the presentation and stuff as we go. Everyone good? You shouldn't say anything. You should be on mute. All right, what I'm going to do is play the numpty clip over again from yesterday. It's really good. And then talk about the rebuttal. And then we'll move from there. Here we go.
You got Save the Shake still open, John.
Say again?
You got one line still open. Save Shake.
Don't worry about it. Just get him, Betty.
What?
Somebody's line's open?
No,
They've corrected it.
Okay.
Thanks, Shake.
Yep.
All right, we're good to go. Here we go. Shama Lama Gamma Panda Ding Dong. Hammering away at the C4 fire again. March 2021. Shama Lama Gamma Panda Ding Dong. Hammering away at the C4 fire again. March 2021.
You can look up and you can see a rocket working in a vacuum.
Oh, really? I've looked up plenty of times. I've never seen any rockets working in a vacuum. And where'd you get this vacuum from? You know, besides the one in between your ears? Clown.
Saying we don't know it's a vacuum is not true. We do know it's a vacuum.
You're a daisy if you do. So a nuh-uh, and you do know.
You have no reason to believe it's anything other than a vacuum, and lots of reasons to believe it's a vacuum.
Why would we need to believe in the first place, you fanatical religitard? Have you ever heard the statement, nature abhors a vacuum, by chance? You know, say for that space in between your ears, have you ever heard that? We have 6 reasons not to believe your horsepucky bollocks. It goes something like this. Boyle's Law, Charles' Law, Gay-Lussac's Law, Avogadro's Law, parts of Dalton's Law, and the second law of thermodynamics that you just violated, you crayon-munching window licker.
We can have knowledge of rockets working in a vacuum by looking at a rocket working in a vacuum.
Profound as usual. Of course you're going to have to find a natural vacuum other than that place between your ears to validate your horsepucky here, clown. Best wishes.
I'm still talking, knobhead.
You calling somebody else a knobhead is akin to Pol Pot calling the Dalai Lama a genocidal maniac.
Hang on, may I say something very important? When you say that rockets don't work in a vacuum, that's not a claim of non-existence.
What? That's a textbook example of a non-existence claim. Keyword, don't. From Hale, Stephen, Thinking Tools, you can prove a negative. Cambridge University Press. A negative claim is a colloquialism for an affirmative claim that asserts that non-existence or exclusion of something. Ergo, for the claim rockets don't work in a vacuum is a negative claim, therefore a claim of non-existence. You're an imbecile.
Which rocket is it that doesn't exist then?
What? Dude, are you mainlining fluoride? Nobody claimed that rockets don't exist. You glue, sniff, and git. The claim is rockets don't work in a vacuum.
This begins with the claim that rockets don't work in a vacuum.
No, it didn't, you dude-licking fungus muncher. The entire argument began with your positive claim right here.
You can look up and you can see a rocket working in a vacuum. You can look up and you can see a rocket working in a vacuum.
You get it? Get?
Jem, claiming that
No.
rockets working in a vacuum exists?
No, look, you can't
No,
just...
you're not?
You can't just... No, I'm not.
You're not? Then what's this?
You can look up and you can see a rocket working in a vacuum. You can look up and you can see a rocket working in a vacuum.
Do you even know where you're at?
You can't just throw the word exist on the end of the sentence and go, aha, it's a conversation about existence. It is absolutely not a conversation about the existence of something.
It absolutely is. By definition, you clown. If a negative claim is one of non-existence, and it is, we just went over the definition by Stephen Hales, then a positive claim that you made, by the way, is ipso facto a claim of existence. You're a certified ignoramus.
It's about engineering and how that engineering works in reality. And you are making a specific claim about that engineering, as are we.
The claim isn't about engineering, Mr. Magoo. Your claim is about a rocket working in a fairy tale vacuum. Wake the hell up!
Who's saying we know rockets exist, but we're saying that they go off.
Right. Well, Jeremy's saying that this argument about how they work is actually about whether they exist or not. And that's not true.
Of course it's not true, because that's not his argument. Oh my God. You're retarded. You're a retard. That's it.
And he's doing that.
No. You're
Doing that.
strawmanning me.
He's doing that. That's exactly what you're doing,
straw
Jeremy.
manning. I'm telling you, rockets Hold on, Jen. Let's just so we're
He's
clear.
starting to spiral now.
You guys are saying rockets working. You guys are saying rockets working in a vacuum is a thing that exists, correct? Or am I
No.
straw manning you? No, you're not
You
saying
are
that.
straw manning me. That is incorrect.
Nah, that's correct. Let's take another listen.
You can look up and you can see a rocket working in a vacuum. You can look up and you can see a rocket working in a vacuum.
Clown.
Okay, let's go back to my question that I asked before.
What about my question?
Give me an
Rockets
example.
work in a vacuum, Jen.
Give me an example of a rocket that you claim does not exist. If you're not saying rockets don't exist, and I'm not saying rockets don't exist, this is not an argument about the existence of rockets.
Hey.
Hello. It's for you.
Yeah? You've just been erased.
Sweet, right? Let's stop her. There
Two
we go.
roast beef sandwiches
Hey,
for $10.
Eddie's. Put a sock in it, soldier. All right, so we had that belly laugher, right? And the response to that, obviously, as I discussed before, was the disheveled monkey 2015 argument about the rockets in like a small little vacuum chamber. Nobody ever gives the torque value. The volume of the vacuum chamber is so tiny, right? Everyone knows what the deal is, but we're gonna go ahead and show everyone here in a second. Hold on, let me get this going.
Is that the that you were sent, John? That on you shared with us earlier,
Yeah, the one it was
yeah.
the response that I got in Discord.
Before you show it, I'd never seen this, and I'd kind of referenced something that Rob Durham did back 5 or 6 years ago, which was basically strip a kind of rocket that you get for bonfire night in the UK, stick it on top of a kid's toy, and put it in a long vacuum chamber and see what happens. We got a slow response, is what I'd say, which was hard to draw any real inference off, and that's why I like this. Basically, the thing didn't do a lot at the start, which is unusual. I said to John earlier, there's a phrase in the UK, it takes off like a rocket, and the reason something takes off like a rocket is actually at the point of takeoff, the rocket has something more substantial for the thrust it's generating to work against, and that it's called the ground. So when we say it takes off like a rocket, that's its most powerful point, because it's got the greatest thing to push against. The rest of the time, that does diminish as it gets actually less and less to push against. So its thrust net effect diminishes. And that's the point of this great example, as it's got it on a, I'll say the words, John Newton meter. And I think in the first second to 2 seconds, it really does demonstrate that. You can see the full thrust firing, ignition's there. It's yeah, I'll leave it with you, John. But
Yeah, we'll head
real
back.
Good example.
We'll head back to the 1 or 2 seconds, but this is, like I said, this is the response that I got last night. I wasn't really paying attention. I just posted the Shamalama Gamma Panda Ding Dong video in there. I left and did something else, and then I came back and I seen the response, and it was from Dead Ed Freeze. He had a new name, Elevator Squared, or who knows. He changes his name like every other second, it seems like. But this is what I got. So let's check this out.
Not only did our solid rocket motor burn in a vacuum, but it also produced thrust during those initial moments of ignition, which is exactly what I was looking for to support Newton's third law, because any thrust produced under these conditions is produced off of the pure reaction of the fuel burning and not from the thrust pushing against air or an atmosphere.
I'm just going to stop it right there. This is a joke. This guy got to be...
Wow.
This is 2015 nonsense, folks. And like, it's ridiculous. Everyone knows that it's filling up the chamber. It's no longer a vacuum. Hello, McFly. So,
Not
go ahead.
not just that. Not just that. Even the blocks that's close to the thrust is already causing. Once that smoke is there, it's causing thrust. I mean, quite simple.
This is the one you
Very
wanted,
small
Adam.
volume.
I think somewhere. Let's go back.
No, but before you do that, the other thing I just picked up on there was I think we were chatting too much, but I picked up on his language there. So he's ascribing that initial effect, not because the chamber's already filled up because it's so small and particles move so fast. He's ascribing that initial effect to not the reinstatement of a microatmosphere and a growing microatmosphere, but down to Newton's third law, which I find,
Yeah, we're going to deal with that. Like I said, the presentation I cobbled together, we're going to deal with that here in a few minutes. But folks, this is a belly laughing joke. How did they get away with this? I mean, doesn't anyone in this video, I didn't go to the YouTube video, I just downloaded it. Doesn't somebody say something? I don't know what to say. It's a belly laugher. Incoherent second grader can debunk this, folks. Ridiculous.
I mean, if it was still a vacuum when this happened, that wooden shard would not be moving around.
just a quick question, Flatsoid. A vacuum's foggy.
No.
Okay, then.
Too funny. Okay, let's get rid of that. Yeah, this is funny, but I didn't want to give away the whole punchline in the end. Let's get rid of this.
Funny.
And let's get Discord back up. I'm starting to get good at this.
I have a question.
Go ahead.
I didn't think that there would be a flame or something. Why do you think that the initial startup of that thing has produced a flame?
Well, you got the oxidizer within the chamber. That's why.
Which chamber? The
In
vacuum chamber?
with the propellant in the tanks, in the fuel tanks.
Oh, okay.
Yeah,
So
it doesn't come from outside. But anyway, hold on a second. We don't know what the torr level. I don't think he even had a gauge with the torr level or pressure level on it. I didn't see one. Did I miss it?
I didn't see one either. I was looking for that.
Yeah. So the oxidizer's already in with the fuel tanks. So it comes from within, not without. Good.
Can we do a radio check for Arwin? Because I tried saying something earlier.
Oh, sorry about that, Arwin. Go ahead. Your last radio check. Go ahead.
Yo, hear me?
No.
Still low.
That's all right, man. Just like I said, take one for the team on this one. Yeah. We'll get you back. You need to buy a new mic, man. Go down to Dollar General there in Dutchland.
Am I coming in?
Yeah, thanks a lot, Neil. I'm trying to listen to Arwin. Yeah, you're coming in.
Oh, thank you.
Very new.
Yeah, you got some problems with it, man. So take one for the team. You know, take a bench seat this time. We got it, man. I'm going to bring out the Louisville Slugger here in a second. Capiche?
Good.
Check.
Oh, that's better.
I unplugged it and plugged it back in.
That usually works. Yeah,
So you're
good,
working
Arwin.
IT, do you, Arwin?
Yes, it's the best advice ever.
Turn it off and on.
All right, folks. So let's take a look at this. Like I said, I cobbled together a short presentation. I don't think I need to spend any more time on their little rocket in their fairy tale non-vacuum. I don't need to do that. So, but I did cobble this together. I wanted to show you this. Nathan, hopefully you're not listening. I wanted to show you this train wreck of a dumpster fire in print and use their incoherent second grade words against them. It's preposterous. Wait till you see it. So let me start off by saying, number one, this is for you, Nathan. There is no vacuum of space. It's a second law of thermodynamics violation. Well done. It's over. There's nothing you can do about it. It's done. In fact, it violates all the gas laws. But we'll just post the second law and be done with it. So this entire argument that I'm going to put forward is painfully moot. Just to get that out of the way. We want to take a look at the under or inner workings of how they come up with this nonsensical buffoonery. So, we're going to concentrate on thrust here. So, whether thrust is generated by a rotor moving matter in its surroundings, plane, boat, helicopter, or by stored matter that burns, thrust requires a medium with which to interact. Do rocket engines' capacity to create a pressure differential exceed the surrounding volume's capacity to absorb or displace it frigging immediately? That's the question. I wrote this years ago. Had to be early 2016. Right? So let's check this out. Let's use NASA's words against them because it's real easy. These are two different documents, both by NASA. So they put the first one in this document, and it defines thrust. Let's check it out. Thrust is a mechanical force, so the propulsion system, very important, must be in physical contact with a working fluid to produce thrust. This is another very important phrase right here I want you to concentrate on. The propulsion system must be in physical contact with a working fluid to produce thrust. Now, in a completely separate document, I went to find, okay, how do you define propulsion system? So, and they did it for me. The propulsion of a rocket includes all the parts which make up the rocket engine. The tank's pumps, propellants, powerhead, and rocket nozzle. Do you see any problems just yet between the first and second statements? Propulsion system must be in physical contact with a working fluid, right? The propulsion system is its propellants. See the bullshittery? Everyone catch it? Here, I'll show you. Let's see. If the propulsion system, which includes propellants, that's the frigging fuel and its byproducts, folks, has to be in physical contact with the working fluid, then the working fluid can't be the fuel and the byproducts because it's part of the propulsion system. Get it? If it is, then you have ye old-fashioned law of friggin' identity violation. It's just that simple. So I think they anticipated that. Maybe they didn't anticipate somebody finding this out, right? That their train wreck statements contradict each other. Here's what they're doing. Check this out. So in the same document, the propulsion system document, as this little bugger right here, right? The second statement. Check this gem out. I'm going to read this a couple times for you, see if you catch it. For a rocket, the accelerated gas or working fluid is the hot exhaust produced during combustion. This
Objection!
Stop! Let me start over. For a rocket, the accelerated gas or working fluid is the hot exhaust produced during combustion. This is a different working fluid than you find in a gas turbine engine or a propeller-powered aircraft. What? Turbine engines and propellers use air from the atmosphere. You see it as the working fluid. You see that? That's a key term, key phrase. But rockets use the combustion exhaust gases. What? You guys get it?
Yes.
Do you guys get it out there?
100%.
I'll stop for a second then, because I know people are wanting to talk. I can hear them in the background. Go.
I'm not. I had a little exposure to this, and it's naughtiness. And you need the other statement, I think, as well, John. The first definition of working fluid. So naughty. It really is. Exemplifies the naughtiness.
They're naughty. I like it.
Shenanigans.
Yeah, the working fluid is part of the propulsion system, right? So, do you hear? This is a train wreck of epic proportions. I'm going to read it again, and just in case you didn't get it the first time, maybe you get it second. For a rocket, the accelerated gas or working fluid is the hot exhaust produced during combustion. This is a different working fluid than you find in a gas turbine engine or propeller-powered aircraft. Turbine engines and propellers use air from the atmosphere as their working fluid. Really? But rockets use the combustion exhaust gas. Number one. Here, you see this? Did you see this different right here? Right? Why is it different? Don't gas turbine engines and propeller-powered aircraft produce hot friggin' combustion exhaust gases, you clowns?
John, can we have the definition of working fluid again, please?
I think it's in the first one. Working fluid, where would it go? But propulsion must be in physical contact. We don't have an exact definition. The propulsion includes, it just talks about the propulsion system.
The propulsion system, and you've defined what that is, must be in physical contact with a working fluid to produce thrust.
Yep.
Now, the only thing I'd say is, when I said about a rocket taking off like a rocket, the reason is it's not actually got a working fluid. It's so powerful, it's got a working solid at that point.
Yes.
That's my
ground.
Yes. But once it gets away from the ground, so the ground is no longer in play with regards to affecting the redistribution of the working fluid around it, then there is only the fluid that's generating the propulsion. They take that definition, and then there appears to be in the next statement like I said, the shenanigans. They then redefine the term working fluid, which is contradictory to this statement.
Yep. That's what I said. Why is it different? Though gas turbine engines and propeller-powered aircraft produce hot freaking combustion exhaust gases. You clowns! This is proby. Like he said, it's not. It's atrocious, egregious, shameful, deplorable, pathetically pitiful. Right?
Yeah.
Why didn't anyone catch this?
It's a damn shame.
Hey, what's up, Chocolate? It's a damn shame, ain't it?
It's a damn shame. This is terrible.
Yeah.
100% word salad.
How you said that the propellers use the air from the atmosphere as the working fluid, but the working fluid is also the propellant. Like, are you serious?
Well,
so by that statement, the air from the atmosphere. So then, how is it working without atmosphere?
Yeah. See, they make the working fluid the hot exhaust produced during combustion, right? But they contradict
in that
the other
instance.
Yeah.
It's the banana in the tailpipe, man.
Yeah, it's the banana in the tailpipe. This is a train wreck of epic proportions, people. This is so belly laughing on a second grade level. It's belly laughingly funny. Get a rocket scientist in here. I want him. Lucy's got some splaining to do. I'm telling you that, right? They can't explain it.
How did this guy write this statement?
I don't know.
Knowing that they claim that rockets are supposed to work in a vacuum. This statement right here: the turbine engines and propellers use air from the atmosphere as the working fluid.
That's the switcheroo, isn't it?
Yeah.
But it's not. That's the clever thing, because if you actually think of the engineering, and you go, gas turbines and propellers take the air from the atmosphere and they use it just like a rocket generates its own. That's what they want you to think. They're pretending that what they take in is being used as a working fluid. It's not. They nick a little bit of the air that isn't part of the working fluid mechanism in front of the turbine. Yeah. What comes out the back is exactly the same as the rocket. It's still having it. Yeah. It's just you haven't nicked the bit out the front. You've already stuck it in a canister inside the rocket. So naughty. to confuse
what they,
as if you can then replace that exhaust fluid to make it the working fluid. And that's the shenanigans from the first bit, the way they say for a rocket that accelerated gas or working fluid. And this is the lie. So they're saying the working fluid for a rocket is the hot exhausted exhaust produced during combustion. Where's that hot exhaust going? And straight out into a vacuum by their claim. What point is it coming back to generate thrust or impedance of the rest of the stuff that's coming out? It never does.
can I say something?
That's how to get you, man.
Go ahead. Somebody else wanted to say something out there. Go ahead.
It's Paul. I was thinking, and I'm just trying to think of it just logically myself. But, a propeller on a typical prop plane is technically the propeller's pushing the air kind of at some point, but coming in contact, pushing forward. Even a jet engine works the same way. So what is the propeller pushing on again? I think that's, am I getting this right? What is it pushing on? Nothing, right?
With the plane propeller, what the propeller's doing is condensing normal air and thrusting it into the working fluid. There is no working fluid the other side. The propeller is converting normal air, right, and turning it into the equivalent of the combustion, but by condensing it with the way the propeller works. It's that condensing and pressure differential that creates the thrust onto the working fluid, which is the same air technically, but isn't in terms of definitions of working fluid and then the acting fluid.
Yeah, and I
agree, John.
Yes.
Sorry.
Go ahead. Go ahead, Paul.
Yeah, I was thinking, one thing I did when you said pressure differential, I thought about that. I was like, a propeller or even a jet engine is creating a pressure differential. That's what causes the thrust. But where's the pressure differential in a rocket? Is there one?
No. There's, like I said, all there is the thrust of the rocket coming out the other way. So there's no impedance to generate thrust. All that happens is the stuff comes out and goes. Off it goes.
Right,
yeah.
So
the only thing you...
I'm sorry.
Then you're getting into what is probably something for John to cover later, which is the claim of Newton's third.
Oh, you're really, really...
No, which is why I said to go outside of that, all you've got is that. Yeah? You can only have any other claim. So outside of that, that's all that's happened if you're talking about thrust and the behavior of gas particles, and how they generate thrust. That's it. If you're pumping those gas particles into a vacuum, there is no thrust generated because there's no impedance.
Well, somebody we need to get a rocket scientist in here, somebody aeronautics engineer, come on, and explain these statements to us that train wreck themselves. They're contradictions. This is easy to pick out. I could do it in my sleep. The second question, how does a rocket... hold on, just relax. Let me get through this, and then you guys can have a free-for-all. How does a rocket propel itself in the atmo? Oh, man. You dumbasses. I don't know if you get it. I'm not going to explain it to you. What about a solid fuel rocket? Where's the working fluid? Oh, the exhaust again, huh? Unbelievable. See, that's not the game, though. I'm going to tell you here's the true appeal. You ready? This is the true appeal from the same document. Different propulsion systems develop thrust in different ways, but all thrustage is generated through some application of what? What in the world? Thank you. Appreciate that. Time to get it medieval. Now, the official date to start to get medieval on Newton is tomorrow after the Rumpus Numpty clip. That's for the general public, but I'm going to get medieval on NASA right now. I don't usually do that, but it calls for this. Okay? See, they're trying to spin this Newton's law of motion. Let me ask you a question. Why does secular pseudoscience admit that Newton's laws are bunk, and we have NASA appealing to it for their knucklehead thrust? Why is that? I don't know what to say. NASA, you can go back to your alma mater wiki. You better correct this. Newton's classical mechanics were superseded in the early 20th century when Albert Einstein developed the special and general theory of relativity. So you need to come up with something different here, something with Einstein, not Newton. My word. From Professor Jacob D. Bekenstein, this is from Caltech. Einstein also replaced the Newtonian law of motion by the statement that free test particles move along geodesics, the shortest curves in space-time geometry. What? What are you doing, NASA? Caltech's going against the stream here. Friggin' bozos. Douglas Klein, professor of physics, Phys Libre text. Listen closely, NASA. Newton's two crowning achievements, the laws of motion and the laws of gravitation that had reigned supreme since published in the Principia, shout out to Adam, in 1687, were toppled from the throne by Einstein. Why are these people saying that these laws, that they're bunk? But you're using them to grease the skids, right, for your fairy tale thrust. Why is that? Do you think no one's going to notice this? This is a train wreck. Oh, by the way, spinning space monkeys, time to wake up. And you're going to wake up tomorrow and start mindlessly parroting the correct pseudoscience, relativity, general and special relativity, and start brushing up on your differential geometry and tensor calculus skills. We'll leave the light on for you, okay? Because as of this point, I am not dealing with anything from Newton from you guys. You'll hear it tomorrow. I'm not going to give it away right now. Let's go even further. From Richard Feynman. Richard Feynman, are you listening, NASA? Richard Feynman's going to tell you. Pay close attention. The discovery of quantum mechanics first, and then in the behavior of light, and then in the behavior of matter, finally culminating in 1926 with a full equation of quantum mechanics, which told us that, listen up, the laws of motion of Newton were not right. NASA, why are you still using them to grease the skids for your fairy tale thrust contradiction parade? Richard Feynman's telling you they're not right. Everyone else is telling you that. Why aren't you listening? My word. From Professor Shankar, Chair Professor of Physics, Yale. All right, so today we're going to shoot it down, Newtonian mechanics and Maxwell's theory. Electrodynamics. We'll get back to him another day. I digress. Let me start over. All right, so today we're going to shoot down Newtonian mechanics and Maxwell's theory. We're like the press. We build somebody up only to destroy them? Professor Shanker's going to destroy Newtonian mechanics. Really? That's interesting. How can you destroy them? You can't because NASA's using it. Professor Shankar? Here he is again. First, I want to tell you what goes wrong with Newtonian mechanics. The double slit experiment is a problem. That's what puts the nail in the coffin for Newtonian physics. I wonder what that means. The nail in the coffin. Does it mean it's rebirthed? I don't know. But these are just gentlemen in citation just saying, this hyperbole, right? Here comes the cowbell. Ready, clowns? So we have a double slit experiment with a Newtonian particle and electron. We close one slit and fire a bevy of electrons and we get 10 hits at point A. We close that slit and open the other slit and fire a bevy of electrons and we get 8 hits at point A. The Newtonian prediction would be if we fired that same bevy of electrons with both slits open, we must get 18 hits at point A. Must. Well, what do we get? We get a big fat 0. And what does that mean? Professor Shanker, can you tell him? Here, I'll put it right up in the middle of the screen for you. That is the end of Newtonian physics. NASA, what's going on, man? What you doing? You're holding two positions that are contradictory at the same time. Everyone else is on a different sheet of music than you guys. I guess you're special. So in relation to Newtonian, anytime you hear classical mechanics, they're talking about Newtonian mechanics. So, in relation to that, what does shoot down the nail in the coffin, destroy, that is the end of, and the laws of motion of Newton were not right? What's that? Baltards, what's particularly confusing about this? NASA, what's confusing about this? Might put it in Braille and shove it. I went on mute. You get the picture. This is a joke. This is a belly-laughing joke. They could be defeated in our sleep using their own words. I'm going to let you go. Questions, comments, concerns?
Somebody in the chat says something. Says like, the gases of the chemical reaction pushes against the exhaust and the exhaust pushes back.
It pushes against the exhaust and the exhaust pushes back. Really? So when an exhaust hits a vacuum, the available space of that vacuum, it's going to push it off. Really? I'd like to see that. Can you show us that?
That was the point.
I want to see that.
Right. Wouldn't the exhaust have to pose some kind of resistance?
If you go and stick your mouth to a vacuum and try and blow out, what's going to happen?
Well, let me say it another way. If you have a vacuum and you have a balloon, right, and you open the balloon up, then you find that the thing won't fly off, right? It just puts the air out, and that's it.
Yeah, it cancels the motion.
But if you sort of release a full balloon in a normal atmosphere, you will see that it will fly off in all kinds of directions, because it pushes off of the oxygen that's already in the room. But if there's none, it doesn't push. So if you're falling from a plane and something else has fallen off that plane, and you sort of try to jump on that object, maybe. Suppose that you would have thrown a wooden plate off the plane, and you're also jumping off the plane, and you would sort of jump on that wooden plate and sort of try to push yourself off of that. What do you think the result would be? Right? You wouldn't get any. It doesn't work.
Right? Isn't it just a change of matter, not energy, anyways?
It's all bunk. I don't see
that would only work if you take all the air out, because that makes sense.
Yeah.
People need. Sorry, Betty.
No, go on.
Sorry for stepping on. I'm not just stepping in on Adam, on QE, and on Betty. I'm sorry. I apologise.
No, go on.
People need to look at the reason for rockets. The original reason for a rocket was to get something, a ballistic weapon, right, to go up high and then arc down onto somewhere. That was the original reason for a rocket. Planes that use rockets, right, the most futuristic one that we know of is the SR-72, which replaced the SR-71 Blackbird. And the SR-72 has a maximum altitude of 15 miles. That's what's claimed. The whole point of a rocket is that it assists, because in high altitude where there isn't a whole lot of air, it assists the plane. But it still has to have air there to push off of, even at high altitudes. Where there is no air, it won't be able to fly. Otherwise, the SR-72 and other ones like it would be able to fly up higher to claim 15 miles. The ballers don't understand this. The whole reason for a rocket was to gain altitude, but it's still, if you're going to use it within an aircraft, you still need air to push off of. You know, that's the whole point of it.
Yeah, not to mention.
One second, flat side. The reason NASA, just to throw this in, because I don't know if I get a chance to talk again, the reason NASA keep on using Newton, right, is because in every video they ever came out with, from the start, from their moon landing, showed Newton's force of gravity attraction. That's why. No, sorry.
I'm saying, and don't forget to mention that even like the X-15 rocket, where they actually had to fly it up and then let the rockets taken off, it only has its maximum thrust as it starts. Once it's started, the thrust diminishes as it goes past. The rocket works at optimal when it's taking off. When that thrust is gone, it's gone. It just depletes.
That's exactly what I sarcastically said in an old phrase, taking off like a rocket. Backside, you're probably best to... To me, this just explains the majesty of gas behavior. Yeah, it really shows how powerful intermolecular forces are. Yeah, that they can push something as heavy as the rockets we see take off, upwards with such great force. Now, there isn't anything physical. It's genuinely, it's pressure differentials, isn't it, that we're creating? And I think John in the presentation describes it really well. It's the inability of the system to dissipate what's being created quickly. And in doing that, that power dissipation, that increase in pressure, or generally is what it is, but that increase in pressure has not only the big thrusty rockety effect, as we see, making all the, but because the system is unable to dissipate that, actually some of the power is dissipated back into the rocket, pushing it forwards. And that's why it's most powerful at the ground, because it isn't just the air that's impeding it, it's the ground which it impedes it significantly more, hence why it takes off like a rocket. But as you're saying, the understanding that as we go higher in altitude, the air diminishes in pressure. Therefore, by its very definition, as it gets higher, its natural thrust diminishes based on gas behavior.
Well, right. Don't airplanes utilize about 90% of air anyways?
You see, that's why you get Harrier craft jets when they want the walls.
Airplane?
Yeah, like the carrier jets, where they got the push-off walls on those on the ships, for that reason, because it builds up the pressure against the wall, and that's why it's able to have that thrust to be able to pull up at such short distance. It doesn't have that wall, it's not going to have the thrust it needs. It's the same principle. If you lying against a wall and someone pulls that wall away, you're going to fall, because there's nothing to support you to give it pressure to push back. In a vacuum, if there's nothing to support the gas to push it back, you're not going to have any thrust. You're just pushing that energy into filling the available space. That's it. Nothing further than that.
Cool.
And something else.
No, go ahead. Go ahead.
And something else. I mean, like on either jet engines or even on rockets, they have the bells, or they constrict the flow or the thrust to make it more efficient. Because I think that even as they already admit that the higher you go in the atmosphere, the engine itself becomes less efficient. So they have to do something to compensate. So why does it become less efficient? It's not pushing off something. You guys understand?
Because the working medium, working fluid
precisely
is becoming.
Yep, you got it. Go. Sorry, Adam. Go.
No, well, that's it. That's the whole purpose. So when you get to the point that the working medium, as they describe, has zero impedance, what thrust do you get from zero impedance? Zero.
What working fluid are you talking about? The propellant itself, or the air from the atmosphere?
The air from the atmosphere is the working fluid, as correctly described by them. However, when we go in and working fluid creates impedance, how much impedance does a vacuum create?
None.
You go.
So it's like, hey, don't worry about that. Look over here. Hey.
Well, that's the point of the last part of the presentation, isn't it?
Yeah, it's the same okie doke as all the other ones. Like, oh, we do have a geometric horizon. We don't, right? rays are they're divergent. Oh, they're parallel. I mean, it's whatever they want, whenever they want it. They think these arguments are like a Chinese buffet. Just get what you want. Just use it. Nonsense. We're paying attention. Words have meaning. Cut it out. This globe crap.
I don't know if you guys have watched that full video of that so-called rocket in a vacuum. You know, that wasn't his first attempt. That was, I think, it was like the fourth or fifth attempt, because every time he tried to let it go off, the pressure itself built up so much that it ruptured the chamber. So that alone debunks it.
Wow. I was going to say something, by the way, about am I coming through?
Yeah, you're good, Arwen. Go ahead.
Cool. Yeah, the whole thing about using a rocket propelling, it's what they call it, a controlled explosion. Well, it's thriving on having gas in its direct vicinity to press upon, which can only maintain itself if there is a container. So effectively, in an indirect way, rockets can only work and propel themselves within a body of gas if it has a container to eventually press upon indirectly through all the gas within it.
That brings up something else I want to bring up. I was going to ask Adam about this one. Doesn't chemical processes to occur, especially with a gas or a liquid, there have to be under pressure, because the molecules will be too far apart for any kind of chemical process to occur?
I think you could probably generate that. Hence, this is the point as regards to like a internal combustion engine, where you are taking in thing. This is pre-mixed at the point of ignition. Yeah, so you could quite with the rocket, the way the rocket itself, that's perfectly feasible to get it to the point of ignition. I wouldn't dispute that. The point is, after ignition, off those particles go. At what point do they create a return for the new particles that are being created to be impeded, to therefore generate thrust against the mechanism causing that combustion in the case of a rocket? That's the issue. I wouldn't need to argue whether it's possible, because I think it is possible to create combustion in a vacuum if you've got the oxygen and the other combustor, the explosive reagent. If you've got those things to put together at the point of combustion, no different to why your car tank don't blow up. It only explodes at the point of combustion, and you put that point of combustion in a contained area. That isn't the same as a car, is it? With a rocket, that combustion isn't the thing generates. It's the escaped exhaust of that combustion and what impedes that escapement that causes the thrust in a rocket. And we're saying there isn't anything to impede it.
Right, it's all controlled explosions within the container. In a car engine, it's the cylinders, right? That's where the explosion takes place, and the chamber causes the thrust from the explosion in order to set in a motion and then translate that mechanically. But it's all about the pressure on the container that actually causes the explosion to have the pressure it does.
If rockets worked in a vacuum, militaries use, let's say, rockets off of missiles off of an airplane. Let's just say a jet fighter. What it does is it flies along. Once they release the missile, it flies along. Then it goes down and hugs the ocean. Right? Now, the reason it hugs the ocean is so it can come in underneath the radar. That's part of the reason. But it's not just that. It's for speed, because it has the densest air at that place. So it uses its jet propulsion, right, against the densest air for the maximum speed for it to hit a ship, right, or whatever it's hitting. It hugs the surface of the earth, or hugs the ocean. The ocean is best because they know they can keep a certain height above the ocean and still hit a ship, whereas obviously on land there is undulations. But if rockets worked in a vacuum, they would use rockets that go up the way and then come down at the last minute and hit a ship, because there's all these targeting systems the ships have for taking out the rockets that are coming in, hugging the water. But that wouldn't happen if you had a rocket coming down from above at the last minute and coming in. So if they worked in a vacuum, militaries wouldn't be using hugging the water. They'd be using the vacuum that's supposedly above us. Because that would make sense.
All right, to get it all out, guys?
No.
No.
No, because there's the final point in your presentation, which we've addressed all of that. There's the final bit of your presentation, which is what they fall back onto, which is the idiot idea that when you get into the vacuum of space, you fall into, first of all, 106-year out-of-date rhetoric, but to justify your position, basically you're saying it's the equivalent of somebody sitting on an office chair, you know, with little caster wheels on, swinging a lead weight around, and using that differential as your new thrust, because you've now entered into a vacuum, so you've not got that thrust. That's what they finally fall back onto, and that the point is, John, unless I'm being corrected, is what they're demonstrating there. That's the farcicalness they fall into. It's justified to fall back into Newtonian mechanics. Justify it. That's weak.
Yep. It's the main point that I wanted, after the train wreck of contradictions. I just wanted to show you what their thought process was, what they were using to grease the skids. It's pseudoscience. What are you talking about, right? So that's what I wanted to show. All right, did you get it all out yet, or you want to go a little bit further?
I got something.
I figured you did.
The Newtonian mechanics, why the ballers like it so much, even for this, is because Newton, for some reason, specifically ignored gas properties within his modeling, right? He's only dealing with objects that are susceptible to momentum, and gas is invisible, and he just chose to ignore it within his modeling. And that's why
exactly,
they like
Arwen. When I sarcastically say that model of somebody on an office chair with a big weight spinning it around, think about what's at play. What's the biggest differential? It's the impedance that the gas creates. It's that forces the chair forward. As you pull the weight up, and that creates forces on the impedance that are transferred to the chair. It's not the fact, right, that you're spinning the thing around that drives you forward. That's what Newton never accounts for it in any of his mathematics. It's all about the weight. The weight is held in a vacuum in Newton's, put simply, mathematics. It's sat within no impedance, yeah, and it's never accounted for. It's just the transverse effects of the weight based on mechanics, simply.
So, Adam, you're saying that throwing your hammer and letting it pull you like Thor, that's not cool. Is that what you're saying?
In a vacuum, yeah.
Because it's essentially that's what I picture when you say you're sitting on a chair, you're just swinging a hammer.
I think it's reasonable to think that Thor could fly with a magic hammer, fly from one mountain to another in air, and there would be reason to generate that thrust. But to certainly go from one fantasy planet to another fantasy planet through a fantasy medium of vacuum of space, I don't see even how his magic hammer would work.
Then you don't understand the mechanics, because it's magnetics. Look at even how it is displayed in the movie. It's all
I knew there'd be a wizardry answer.
Yes, it's magnetics. It's like controlling the magnetic fields surrounding the area in order to make it pull because of the magnetic.
Did you just pull incoherent dielectric acceleration on me?
Sorry?
You just claim incoherent dielectrical acceleration as how Thor's hammer works?
Don't start that.
No, this is more like space-time controlling. This is just creating magnetic fields, maybe more telekinetically in the environment. I think it would be more down the lane of cymatics.
Oh
right?
God,
Except
we're headed off the rails. We're headed off the rails. I'm gonna
nerd rage.
Yeah,
Hurry up before Don Gio jumps in.
No, it's more than nerd rage. I'm gonna reel this bugger in. So like I said, we got Ed Freeze was the one who provided the 2015 disheveled monkey, and you're going to get a chance to respond here, sir. Floor is yours. Hold on a second. Let me turn you up. Give me a radio check, sir.
All right. 1, 2, 3.
Yeah, we got you. Good. Go ahead.
Okay, so what was wrong with it?
Did you watch what I did at first? The first part?
Yeah, you made up stuff that because there's smoke in the chamber, it's not a vacuum anymore.
Yeah.
That's irrelevant.
Oh, it's irrelevant. So what's the point of it?
What's the point of what?
A lot of smoky
What's the point of what? Hello, McFly. You posted that video as proof of rockets working in a vacuum. Well, the smoke in the chamber makes it not a vacuum anymore. Is that clear?
Could I just add to that point? Smoke is, by its very definition, not a gas, the thing you're seeing.
Sure.
The smoke you see is particulate matter that's held up to give that opaque view by shed loads more of invisible gas particles that hold up some of those carboniferous byproducts. That's the smoke you see. What you're seeing isn't just a couple of particles. It's all the gas that's holding up to give that opaque nature from top to bottom. Otherwise, they'd fall to the bottom, wouldn't they, if it was still in a vacuum?
So, Adam, no gas, then you wouldn't have smoke.
Let Ed respond, please.
Yeah, so I don't see the relevance of pointing out the smoke because, of course, there's going to be smoke, but it doesn't really matter. You can see at the ignition. Hold on. At the moment of ignition, you can already see that there's force coming from the thing.
Yeah, the point of highlighting the fact there's smoke is the point that the second you see smoke, there is no longer a vacuum. In fact, significantly before you could see smoke, there was no longer a vacuum to make the subsequent claim that's going to follow. The next bit of action is invalidated at that point because you're no longer got the same conditions that you claim you've got at the setup. That's the point of mentioning the smoke.
Yeah, it's completely irrelevant. You can see the video.
Undermines you.
Yeah, I figured you would say that.
Relax, Neil. I posted the new video in the chat.
Yeah, I'm not playing new videos in the chat. Stand for what you posted. It's no longer a vacuum, sir.
Well, I'll tell you. I told you I stand behind the entire attempt.
Fair enough. Okay.
It's the part that's in slow motion, and you can see that.
No, you
second
can't.
The thing ignites.
Yeah,
there's already pressure coming out of it.
As soon as the thing ignites, we already looked at it. Adam and I took a real close look at it. As soon as it ignites, and I played it earlier, when it ignites, it's not doing anything.
I think
it's
the
also
crucial
clear in the video that Flatsoid posted. You can see the pressure gauge change as soon as it ignites, so that debunks the idea that it's a vacuum.
Yeah. Oh, right. And the one that I didn't see, the one at Flatsoid post.
If you watch the pressure gauge, it's quite interesting. I want to go back to. Go on, Arwen. You go first.
I just wanted to say there may be an initial bump, right? But there's only any actual lasting pressure starting when the entire chamber is filled up with smoke, right? So it's obviously the failing of keeping the vacuum in the chamber in a vacuous state that actually allows that pressure to build up.
There's another important.
No, that's wrong.
There's another important point here that I didn't bring up. What's the diameter of the tube or the cube or whatever he's used? I didn't look at it. Do you know?
I don't know the dimensions of the thing.
The dimensions. How big is outer space?
Bit larger.
It's a bit larger. It's 3.58 times 10 to the 80th cubic meters. This is a false equivalent fallacy from the nuclear black lagoon.
Well, it's interesting you say that because indeed, when you say the smoke fills up the chamber and that causes the pressure, that's not what's really happening because you can see at first Hold on, I wasn't finished.
No. What's really happening is it's no longer a vacuum chamber. Everyone that can fog a mirror understands this, Ed.
But you can see at the point of ignition, it's already giving
It's
pressure.
not. We already looked at it. Adam, I'm not doing this again. Final words on it.
Okay, well, you're wrong. And the Earth is
Could
not
you
flat.
have that vacuum chamber without the chamber?
What's going to happen in the bigger chamber where there's more space to the sides of it? Huh?
I'm just concerned about the chamber.
What about the chamber?
Yeah, we're not going to get in.
Vacuum?
Okay, hold on a second, Chocolate. We're not going to go down the 18 begging the question fallacy things. We're not going to do that. I wanted to give him a fair shake and to present his case. Okay. Go ahead and present your conclusion quickly, Ed, and that'll be it.
Okay, well, you can see at the point of ignition there's already pressure. And if you're saying, well, the smoke is going to give the rest of the pressure, well, that's simply wrong. Also, wouldn't even matter. Vacuum of space is very large, so all that smoke would disappear. And you would still have the thrust. I don't really see the argument that you guys are making. Also, final point, please. The Earth is not flat. Thank you.
Thanks, Ed. Okay, let's see. Go ahead, Adam.
I was just trying to understand Ed's point was that basically everything we've just gone through, he disagrees with it because he doesn't understand it. That isn't what I heard. I didn't hear a rebuttal to all the stuff that's just gone off.
He said it was irrelevant, and okay, that doesn't matter. Relevant.
Okay, which is fine. I just want to confirm that he didn't need 10 more seconds to make the devastating point.
No, I think his main point where he ended up with is, yeah, it works in the vacuum of space as well without an actual demonstration for that. Right?
And that vacuum cylinder of undefined size replicates everything that will go off in space.
It's a good catch, Arwen.
Supposed
where there's no cylinder.
Arwen had a good catch. You want to repeat that again, Arwen? Good catch. Sorry. I caught it too. Go ahead, Arwen.
Yeah, well, it's simple. He basically said, okay, the vacuum tube, it works out. There is pressure there. And in vacuum of outer space, it should work as well. And then he didn't provide a demonstration or an explanation. He just left it with that claim.
Thanks, Arwen. Yep, I caught that earlier.
Well,
good.
That's why I asked about the chamber.
That Arwen, I think I'm probably being a bit geeky, but that's my that chamber. When I talked about the as John talked about that dispersal of containment of the explosion, and that's what creates the pressure to push back on. The chamber elicits that. How does the vacuum chamber not affect the demonstration? How many particles does it return to the rocket to create that thrust? Yeah, and how is that comparable, that chamber, to the vacuum of space? That appears to be what Elevator was kind of making that is irrelevant. That bit really doesn't matter. Which I think the presentation was all about how important that impedance is. And
I could tell you,
space as a vacuum wouldn't give that any impedance ever.
I mean, I can tell you a way to set it up if you want to do a good experiment. If you can figure out some way to keep the pressure the same at the point of ignition, and the pressure inside the chamber never changes from a vacuum, that would be one way to prove it. Which means you've got to be sucking out as much as being produced by the thrust, and I don't think that's possible.
Yeah, good luck with that little maneuver.
Thinking about it, but John. Oh.
I was saying, good luck with that little maneuver. It's not going to prove anything anyway.
I know. It's not possible.
If you think about the biggest vacuum chamber we've got, which is old Dr. Cox's thing, he does his.
Yeah, it's in Sandusky, Ohio. It's Pembroke Station or something like that. Yep, go ahead.
Yeah. Think about that, setting that experiment up in there, okay, and these things are, what's the speed of a gas molecule? Never mind an ignited one. Yeah, just the ones in the atmosphere.
Right, exactly. I was going to point that out. Good point. Sorry, I didn't point that out. Go ahead. Go ahead.
How quickly before they have an impedance effect, even as minimal, how quickly? Yeah, there isn't a way of setting this up to demonstrate it because nature abhors a vacuum. Yeah, we couldn't evacuate the chamber as quick as the gas molecules would randomly fill it after spending 14 hours emptying it. Can't set that up because nature abhors it. And the thing is, they're claiming that this thing that nature abhors has no containment. And the only way we can set it up is by digging a huge hole, 15 squillion tons of concrete to last for a microsecond. Magic containment that apparently everything happens in. I'm done rambling.
All right, good. Any last thoughts on this? Betty, do you want some other opinions in here?
Yeah. I just want to ask a question about that Chinese rocket that they sort of lost. What do you guys think of that?
I didn't follow it.
There was a news in the news. It was that there was a rocket that was going to fall on this weekend. They didn't know where or when exactly, and it fell in the Indian or Chinese Indian Sea?
Indian Ocean.
Oh,
apparently the Chinese like to put things up
right in their backyard. In the backyard.
Yeah, they like to put things up and just have no control of them. So they tell you that there's a rocket that they have no control over that's going to fall somewhere on Earth, and they have no idea where it's going to fall. Hilarious.
Yeah, and they said they make it out
when it hit the ocean.
They make it out as a big threat, right? And then it falls always in the ocean. It's never ever on land or whatever. I remember that this weekend we talked about it with my family, and I said, they said, well, see, it proves that the Earth is round. And I said, well, I imagine that it will fall in the ocean and we'll never hear about it ever again. And we don't see the debris as well, right?
Left lane. Hold on a second. Sorry to interrupt. Left lane. That's first time you've been in here, man. What's up? Can we move on to him? Betty?
Yeah, sure.
What's up, man?
Not much. What you doing?
Just hanging out, man. Just destroying Newtonian mechanics and NASA. You know, just the usual thing.
Yeah, your everyday stuff.
So what you got, man? Did you want to say something?
No. I just seen y'all was hanging out in here and live. I thought I'd come in.
All right. Appreciate it, man. Yep. Hey, listen, don't take it personal on the numpty clips when you come out, right? You're just a supporting character. It's nothing personal.
Oh, no problem.
All right, cool. Yep.
Who's Left Lane that you're sort of familiar with him?
Yeah, Left Lane. Yeah, you see Left Lane right here? Yeah. Are you asking how am I familiar with him or what?
Yes. So difficult that question.
Yeah, he's got some good color commentaries. He always comes in at the end, and stresses points, and he's pretty cool.
Oh, okay.
He's a numpty, but he's cool.
Well, okay. Or maybe a co-numpty.
Co-numpty mask wearing. Yeah, you know the deal. Co-show, you are a numpty star. Stay tuned on Thursday. Well, we're going to make you a star again. It's going to be fun. I'm sure you have something to say. I can't wait. Everyone get their abacus out. Okay, you ready? All right, Co-show, go ahead. Release it. Release the Kraken.
Hey, what's going on, QE? Hey, I thought it was a great show. I was listening from the bench, and
from the bench.
It's really hard to argue against. To be honest with you, you did a very great job. I did have one thing, if I remember correctly, because I served in the Navy. I know you served in the Army, I believe.
Yep.
And you fired weapons in the Army.
Yep.
I believe. So anyone who's shot a shotgun or rifle,
yep.
They know how powerful they are, and they have this reaction. You got to stick it to your shoulders. If you don't, you'll get the damage. Your shoulder will get damaged because it'll fly back against it. It's because it's got something called kick.
Yep.
And so when you fire a shotgun, a lot of the power is coming out the front of the rifle, and the shells are flying, and they hit whatever they're going to hit. And funnily enough, the exact same force, the same magnitude force, is going in the other direction against the gun in order to make that happen. And that's called, that's what the kick is. The gun actually fires backwards. It's really just an effect of the shell being propelled out the front of the gun.
Okay.
And this same thrust is actually the exact same principle that allows rockets to work in vacuum space.
Allows rockets to work in a vacuum, but a vacuum can't exist because second law of thermodynamics violation, number one.
And also, can I say something about
Yeah, go ahead.
Hold on a second. Isn't there things in a bullet, like lead objects and things that could impede the thrust of this thing that could cause the kick? Just saying.
Well, a shotgun shell is the container, by the way.
That's what I would think.
Yep.
And it does tend to resist.
And then
Hold on.
the material.
Hold on. Hey, Arwen, hold on. Paul's still talking. Wait one.
Sorry.
And also, doesn't lead objects and things like that resist movement? It has things that takes a little bit of to go into it. So I'm just one a little different. I think a rocket's different than a gun. But I'm just
only slightly. But you just mentioned was inertia. Inertia is the thing that resists acceleration, which is why the shotgun shells will shoot somebody and kill them because they're flying very fast at the gun, but they're also much lighter. The heavy gun is going to much of that force is going to be harder to make that gun move. It's got a lot more inertia than the shells, which is why it only bumps you in the shoulder, and at worst breaks your shoulder. You're not holding it correctly.
Arwen, if you want, I want to know what you can think about this when Arwen's talking to you, Kosho. I want to know what the working fluid is, so we can keep the comparison, not a false comparison fallacy, but you can think about that. What Arwen talks. Go ahead, Arwen.
Working fluid. I was just I wanted to add a comment about what Paul brought up about the gun, about the bullet.
Good.
It really is the micro container that causes the controlled explosion in a very small container, making the pressure much higher. And then it is the momentum of the bullet itself, the weight of it as a solid material, that causes it to, keep going. And then there's ballistics, of course, spin, stabilize the trajectory. But it's really the solid that has an initial explosive launch and then uses its momentum and aerodynamics to carry very far, right? But a rocket doesn't work that way. Well, at least not a rocket with that's not meant for explosive ends, because they go really fast. Because it's all meant to go that high pressure, that high speed. But NASA rockets and all those carry materials and potentially people. They don't build up that momentum, right? And then the air pressure gets lower up there, so the thrust gets lower of the rocket, assuming it's not a balloon. And then at some point, the gravity or whatever, the relative density effect doesn't end, right? The ballers assume that it does at some point, and that's how you get the momentum to reach that orbital zone. In reality, that doesn't work, right? It's just going to lose its momentum and then fall back down again.
All right, Kosho, you want to respond to that? You want to finalize your point? We don't got all day here, but I'll give you some breathing room.
I appreciate that. No, I feel like I said the most of what needs to be said about that, but I know it was he was talking about the pressures involved in the shell of the shotgun, which was just in maximizing that reaction. That's exactly right. There is indeed a lot of pressure, and it's that pressure in that small area which allows it to be propelled so quickly out the front of the gun. And it's exactly the same. It's one of the parts of the equation in the rocket equation. The thrust equation for rockets is actually the valve. The nozzle. The nozzle of where the pressure is coming out. So based on the actual amounts of gas and based on the area of that nozzle and the pressure inside and outside, all these things will go into calculating what that thrust is going to be. So
that nozzle would be the equivalent of the barrel of the gun and the bullet, wouldn't it, as opposed to the gun?
Yeah, it wouldn't be
and
the
the forces affected on that. So those calculations wouldn't be applicable then to the forces affected on the gun and how that would propel the gun in space then?
No, it would. Yeah. Like I said, in the rocket equation.
No, you just said they were relevant. You just said they were relevant to the output of the aperture.
No,
which is the bullet, not. That's one way of the force, isn't it? The other way of the force is what you described, which is how that force then plays out as the kickback in the gun. So we can't talk about the output of the nozzle, which is what you're doing. Talk about how those equivalent forces that are being calculated are converted back into the rocket and absorbed. It'd be how they play out that would be motion related, not the ones you're discussing.
No, you're exactly right. That it's going to be I'm sorry, what you said. The nozzle is exactly related to the what the shape of the actual thing is, so the gun and the rocket. But they're both doing the same thing. They're both firing very quickly the mass out the nozzle, and like I said, all those things are going to help you calculate what the actual force is going to be. So the pressure is inside and outside, the force leaving the gun, and the mass and the speed that it's leaving the gun, in the rocket. The same principle.
Thanks, Kosho. Beautiful.
Yeah, I'd like to get it right back on topic and ask you, what is the working fluid?
Working fluid. I don't think I would use the term working fluid. We're talking about the shotgun. But you might be right. There might be a little difference there.
Yeah, there's a difference.
But
yep.
Yeah.
Okay.
But the explosion that happens in the shell, it's creating the gas and all that kind of stuff. The pressure that's created from that explosion. I mean, you could consider that a fluid, maybe, but for me, it's a bit sloppy, so I wouldn't.
Yeah, it is. That's why it's in my humble opinion right now, it's a false comparison fallacy. But I understand what you're saying. Listen. Got a lot of people in here. This is getting a little bit long in the tooth. I may let a couple people go, but before I forget, Betty, did you need to remind me of something?
If I have to do that, you already know.
Yes, I did. Way to catch it. Listen, I would like to shout out my Patreons, right? Because without them, this wouldn't be happening. So here we go. Seedinks. Yo. Felix Hung. James Mays. James, I seen you in chat earlier. Like I said, make sure you hit me up. Bootman. Eagle Plane and Anchor. Shout out. Steve Ohm. Texas Mike. Fireball X. Erwin Yansens. Nathan Thompson. Unicorn Laser Eyes. Jesse. Degas. Mikhail. Morris. Samson. YN. Will Brax. Mel B. Styles. She's in here. I thought I seen her in here before.
Here.
And,
Thank you.
Yep. And Zachariah. I talked to Zachariah yesterday. What's up, man? I'd like to point that out. And very quickly, I thought it wouldn't take a lot of time. I'm not going to bore you guys to death. But they needed shouted out. They're rocks, man. I would like to point out something else. Let me get my act together here for a second and shut that down and roll here, because somebody reminded me I've been a little lackadaisical on pushing my website, and they're right. Maybe I got, like I said, not only lackadaisical, but taking it for granted. Just want you to know it was launched almost, I think it's a little more than a year ago. 23,000 hits. I'm almost speechless. I wasn't expecting that. All over the world, I can pinpoint them using diagnostic tools and stuff. I'm not monitoring you or anything like that. I'm just saying there's some diagnostic tools I can use. I just want to say thanks to everybody. I hope the sites help you. It's outstanding. Proofs of the Creator, Flat Earth proofs, and 23,000 hits is, I'm kind of shocked, right? So we got Proofs of the Creator, right? Just whack it, right? Right? It goes through systematically systematically, point by point by point, and then conclusion. All the points, all the flat earth proofs are that way. Flat earth proofs, I can't go into some. They start to play music, man. I can't have that. So flat earth proof site, I usually go into each one individually, but I can't do that here. So tell your family, friends, flat earth proofs, proof of the creator, if they want, a systematic way of going about it, using it in their arguments or understanding it for themselves. Hook yourselves up, hit up the website. The link is in the description box underneath this video.
And in the side chat, because I put it there.
Thank you very much, Betty.
Yep. You got a super chat, by the way, from Sasha, Unitox Fame. And he says, outside of the stadium, I didn't buy a ticket for Discord. Remember that we made the room a little bit smaller because we wanted to make sure that the live stream would run. You got now 24 people in here. So.
Oh, cool. Yeah, we did it. Sorry about that, Sasha. We were running a little test to make sure the audio would go through good in Discord, and I think it could take more. Maybe next time we'll expand the room a little bit more initially and see where that cutoff is. Right, just to experience it because we don't know exactly where it is.
Yep, you're going to check that out, and it works.
Hey, Kiwi, I had something to say if you don't mind.
No, go ahead.
So Kosho said something interesting earlier that kind of sparked my brain to start thinking. He said something about when he was referring to the bullet in the chamber, and then he said the barrel, because it's the size it is, that's what allows it to have that initial burst and to project it the way it does because of how tight and small and what's able to move in there and whatnot. But at 10 minutes and 20 seconds of the video of that rocket being displayed, it slows it down really, really slow. And you notice that the pressure that initially starts giving off is like really, really, it's weak in comparison. But like you explained earlier, you mentioned it didn't really start to climb in pressure of the force being against that little thing they had until it started filling up with all the smoke behind it. And then you even see things bouncing back towards the flame, if you will. And it just made me think like, okay, so if you want to compare those two, then if it was space and this vast, infinite open area, then that bullet, like if you put a bullet in a huge chamber, like would it fly as far or with as much force? And in this rocket, would it have built so much pressure if all that smoke was not trapped and it just was, expelling into the depths of space, so that then that rocket would never really move because it has
You're pushing on a string. You're pushing on a string is what you're trying to say.
Yeah, exactly.
Yep,
and that's
exactly.
I'll mute myself.
You got it.
Well, I've got another.
What you could
Sorry,
Alan, is you to make this point is you've got that Newton force meter measurements on the containment. You could set up the same system, but do it in an open field. And I would suggest to you that the maximum force generated within contained system, because of the not initially, but once the combustion products increase the pressure past atmospheric pressure, you'll get an increased thrust. I would suggest do it in an open field, and you will not get a force meter measurement as high as the one when you do it in containment. And that demonstrates the whole principle of how rockets work, which shows why they don't work in a vacuum.
I've got another. I'm sorry. I've got another example of a bullet. I mean, if you take a 9mm round that's got a slug in it, or a 9mm round that's just a blank, which will have more kick? The exact same gunpowder. it'll be the one with the bullet will have more kick than the one that's the blank. You understand what I'm driving at? Did I drop?
Yeah, isn't the bullet going to be heavier?
Exactly. That's my point.
My point as well. Right, that's exactly my point.
I know, but if there's nothing resisting it, if there's nothing resisting it, kick.
No, the force that's required to fire the bullet, the heavy bullet, the exact force that's propelling it and the speed, you can take that same force that's accelerating the mass and the bullets at that speed, you put it in the other direction against the other side of the gun, and that's where the kick is. This direction of the kick. It's exactly the principle that rockets work off of.
I just want to say, Kosho, walls and container lives matter. Did you know a shotgun shell is a wall, is a container?
I didn't know that. Thank you.
Well, my point, though, is,
I love that sarcasm.
I mean, my point is this, though: if you don't have anything but just the gunpowder, nothing in heating that, there will be no kick.
You're right. There'll be a lot less kick. The kick won't be concentrated. You're exactly right. That's exactly why.
So there's no atmosphere.
I told you the rocket. Say again.
If there's no atmosphere, then there's nothing for the propellant to kick against.
Well, no, that's not that part of the equation. But that part of the equation is the part where the area pressure, the pressure on both sides, and then the size of the nozzle. That's where that comes in. So that's what focuses the force. If that wasn't focused, if that was an open nozzle, which is a very wide one, you're right. There would be a lot less force, and they wouldn't work the way they do.
So I'm saying is the gas, the atmosphere is the thing that the combustion is pressing on, causing the kick. It has less weight or less mass, whatever you want to call it, than the bullet. If there's no air there, there's nothing for it to push against.
And that video explains it. And like I said, at 1020, when they slow it down, you'll notice that it doesn't take off like, all that pressure until the whole container's filled up with all the smoke, from it. So that kind of explains what you're saying, that it's the atmosphere that it's pushing against at that point. So it's kind of created its own little launching pad, if you will, once it filled up the box. But that's the problem. The space is not a box. In your guys' world, your space is just infinite vacuum, and it's just emptiness. So it will never be able to build up that pressure behind it to really take off. So then, therefore, the rockets, they'll just stay in a place. They won't be able to take off. They'll just be there in their own original spot.
Can I get this clear? Because it sounds like what you're saying is it's the air, the pressure itself that is being applied to the bullet. That is what's giving the kick and back towards you. Somehow the atmosphere that the bullet's going against is what's giving the kick to the gun. It's going against you. Is what you're saying?
No, I'm saying that in that rocket video, it didn't start building up that pressure, meaning it's now taking off against behind it until it built up all that smoke. And if you watch it again in slow-mo, and they show you that it's weak. It has a weak force because it's just blowing into this empty box. And not until the box fills up with the smoke does it then take off, quote unquote. But so now it's kind of pushing against that smoke. It built its own little atmosphere to push off. So in the chamber of a gun, of course, it has the back of the gun, or the back of that barrel. But like you said, it's also the size, because it's so small, and that combustion, it has nothing but to push against that, and then it flies out.
Right. But I don't understand the equivalence then, because if you're making a comparison, then what you're saying is that just like the air fills up that chamber, the atmosphere is the air where the bullet's going to push against to make the gun go the other direction.
No. I'm saying if I stick a rocket out the back of my ship and there's nothing to push against it, the bullet has the back of the barrel, the end of it. And this rocket has the smoke that it created. It built its own little pressure, the atmosphere. So that's what I'm saying. And you need something behind it. I mean, I don't know. I'm just assuming.
Yeah.
It's building to push off of. If you're in a vacuum of space, you're not pushing off of anything.
No,
and you're
that backwards. The rocket is what it's pushing off of. The rocket is what it's pushing off of, and that's why the rocket's moving. The gas is leaving the rocket very fast, and it's pushing off of the rocket. That's why the rocket is moving.
Whoa, whoa, pushing.
The gun's being pushed
You're
off.
never gonna convert him.
Whoa, yeah, no, it's not pushing off of the rocket.
the bullet doesn't push off the bullet. The bullet pushes off the back of the barrel.
Exactly.
Exactly. So then the rocket is pushing off of the atmosphere.
It's not the rocket. It's not the rocket that's pushing. It's the exhaust that's pushing.
No,
it's pushing out the back of the rocket, out the back.
No, it's not. You got you need to rewatch the first part of the presentation. You got big problems with that working fluid. I'm telling you.
Oh yeah.
So listen up. We got about 9 more minutes. Let's see what we got in here. I gave you guys a chance to let your hair down. Biodual. I see you in here. You've been besmirching my good name, sir. Did I take you off mute?
I did already.
Don't be besmirching my good name just because you're a numpty.
That's a good start for a conversation, isn't it?
Yeah.
Hey, he uses that word in The Godfather, Part 2, right?
What did I say?
You were besmirching me, saying that the typical ball-tard. Hold on, Neil. The typical ball-tard cherry picking. You don't even know what cherry picking is.
Oh yeah. When I think that specific situation was 5 or 6 months ago.
I know when it was.
While you were debating Kosho.
I know when it was. I don't want to know their favorite colors. I know when it was. Get to the point. What is cherry picking?
When you presented two sources as if they were two different people, but there was the same person, and then as well as.
What does that have to do with cherry picking?
Something about the military. I guess you had said that they admitted they use flat maps, but the next sentence after your citation stated that they use these flat maps based on a global.
Oh, based on. So they just stated that. They didn't show that. They just said it. That's not a cherry pick.
Citation, so.
That's not a cherry pick. What is a cherry pick? What is a cherry pick? Let me ask you a question. Can scientific documents be cherry picked?
You can remove the context in which things.
No, you can't.
So,
no, you can't.
Probably.
No, I'm going to shut you up because you're a fucking numpty. No, you can't, sir. Let me tell you why. The only possible way to avail the opportunity to cherry pick, which you don't know what it is that if there are more than 2 conclusions available to you, and because if you have more than 2 conclusions, right, and they contradict each other, then it's not a scientific paper or document. You follow me, sunshine? You understand that cherry picking is prevalent in business, in advertising, in politics, but it is never around actual science. You follow that?
Well, I never said your sources were scientific. I just said your citations and sources. You had cherry picked.
No, it's not cherry picking. It's horse shit. You don't know what you're talking about. I just showed that. That what you said wasn't cherry picking. You got the wrong terminology.
If I wasn't removed from the arena of 24/7, I could find exactly where it occurred. And
I just exposed you. So and stay tuned. I think you got another numpty clip. I got you already with one. You didn't know what a hypothesis was or a scientific theory. So what have you got to add to this discussion before we go today?
Well, I would give a big explanation, but you would just take it out of context and then post an empty clip. So.
Shut up. Get out of my friggin' sight. Tired of your numpty bullshit. You want to know the difference between your ass and a pipe wrench, and I already showed that. You don't know what you're talking about. That went well.
Yeah.
Rumpus! Hey, Rumpy! Let's finish it out. Make sure you watch the numpty clips tomorrow. Wednesday, 2 p.m. U.S. Central, 8 p.m. UK. It's going to be your official end. We all know you ended a long time ago, right around June 2016. You remember that? It's on my playlist for debates. Anyone could just go in there and listen to that train wreck of a dumpster fire. I was even green around the gills like 5 days out here, right? You've been walking around whistling past the graveyard like a damn zombie for all these years, but I'm going to officially end you tomorrow. So make sure you're tuned in. Alrighty then. Betty, any admin?
Yeah. Got lumpy gas in a vacuum. He says, thanks, Kiwi, in the super chat.
Thank you, Lumpy.
Lumpy gas.
That's really cool. It was a good show today. I don't want to go for a marathon here. I got some stuff I need to take care of, but I thought it was a good show. I hope you guys got a lot out of it. You could see the double speak, and then, like I said, how they were trying to grease the skids with Newton. I don't know what in the world they're thinking of. Everyone, you got 2 different or 3 different stories, right? Depending on who you talk to, whether it be NASA or actual scientists. I use that in quotations, right? That they're contradictory. They're paradoxes. So somebody's lying. Follow? Let's wrap it up. We're not going to get any final thoughts unless Adam, go ahead. You have one final thought?
It was only to agree with that. I've enjoyed it. It was a old school thing that really hasn't got a great deal nothing to do with the shape of the Earth. It has to do with the claim of a sky vacuum in terms of where they can relate. But fundamentally, about understanding how rockets work, it appears that to keep the pretense that there's a sky vacuum, you have to ignore how rockets work and say they do one thing in the air, and when they reach the magical medium of space, they do another thing that keeps them going at the same rate that they were never doing before, i.e. the cocking of a gun, I think was I used somebody on a chair spinning a weight, but the cocking of a gun, just imagine that, guys. Realistically, with your rockets, that's what you've got. It's farcical to pretend that you could get to those speeds with the just diluted effects that is the fallback position. And I think he points out in the presentation a fallback position that is maintained by Newtonian mechanics fundamentally. I'm done.
Thanks, Adam. Appreciate it. Any final thoughts, Betty?
Do I need to have them?
You don't need to have final thoughts, no.
Oh, good. Yeah, well, I about that whole vacuum thing, I think that if you really think about it and do some imagination, do people have sort of things that they imagine in their heads and see it in front of them, how things would work, and on past experiences, like when being on a swing and you don't get pushed and you don't get anywhere somewhere, right? And more of those things. We all know how it works. Why would we want to debate about it endlessly? It doesn't go. And how can you steer even in a vacuum of space? Propulsion is one thing, and then to go where you want to go is another, right? It's stupid.
Well, Nathan's not going to be happy with you. Nathan, I want to apologize. You are correct, sir, wherever you are. As I said, you don't want to go down begging the question fallacies. People, this whole thing was moot.
One thing to the other, right? But you need to imagine things on past experiences and what you know to be true. And then you can sort of ascertain yourself that it doesn't go the way that people say that it will go. And I think there's some sort of behind layer that people like to be sort of escaping this world in somewhat ways. And well, let me tell you, people, we ain't going nowhere. We're stuck on this place until God decides that we are going somewhere else. And please make your decision, because there's 2 places, the good one and the bad one.
Amen. Are you? Is that it?
Well, last super chat.
Go ahead.
For Sasha, he says, if rocket, then chamber, then smoke, it's globe.
Yeah, you don't know how funny that's going to be later.
Mm-hmm.
Sasha, you don't know that was it, as soon as you said if, I said, oh no, here we go. Yeah. We're gonna hook that one up later. Like I was saying, folks, the whole argument was moot to begin with. I just wanted to show you the doublespeak. That's all my mission was here today, because we have a standing second law thermodynamics violation. It's cut and dry. There's no question. There's nothing you can do about it. Right? So I want to thank everyone that showed up today. I appreciate that. We had a whole bunch of people in here. It was one of the biggest shows. We might do this a little bit more often, and maybe just make it an open discussion next time, Betty.
What?
Yeah, maybe just make it an open discussion instead of having me present. I just want to do it for some reason. I don't know why.
Yeah. Well, I like the open discussion, and then there is an open discussion. We got so many people in here, and then you want to close down early, right?
I'm not closing down early. We're already past the time limit.
You make it go on and on and on, and then I think, well, I want to hear some globies. There were some globies here. I really would love to hear them.
We heard
4 more hours.
No, 4 more hours. I'm even over the time limit that I spent. We've been here for over 2 hours. Listen,
yes.
My presentation, don't rumpus me. My presentation wasn't that long. I tried to get through it quickly so there would be open discussion, and that's what you got.
Yeah, but we have most of them were unmuted flatties. We didn't get much globies in.
Yes, we did. We heard from the globe, and it was relatively nice.
Yeah, there were more of them, and I wanted to hear them.
Relatively nice, except for Biodual, who was a little butthurt, right? And had to besmirch my good name. I won't stand for that. Especially he doesn't know what the hell he's talking about. Let's move on from that. Remember.
You got another super chat, by the way.
Go ahead.
Yeah, he says, next time tickets to buy, folks.
Thanks. Who was it again?
That was Sasha.
Sasha. Appreciate it, Sasha. So we're going to wind up things here, folks. Like I said, I want to thank all the guests, especially all the audience members. Hey, shout out to you guys out there. And I know I already said this like 5 or 6 times. Listen, this point is moot. Rockets in a vacuum. It's you couldn't get any more moot. It is a second law thermodynamics violation, a begging the question fallacy of unimaginable proportions. So keep your eyes out for the numpty clips. Like I said, we got a great one tomorrow on Wednesday and another one on Thursday from Kosho, who was talking in here before. So don't miss those. So take no prisoners. No quarter will be asked. None shall be given. And remember, I'll be back.